First, there is a concept of the speed. The speed is the distance per unit time. And the units for that one comes to be meter per second. Meter per second, there are two different formats for writing that one, ms. These are two different formats for the writing of meter per second. Once you have to convert the units, suppose there is a speed that is a 90 meter per second. We have to convert that into the kilometer per hour. Hence, we will divide it by 1000. Now, this is a second. The second is to be converted into the hours. Means we have to divide by 3600. That will goes to the numerator. And by that, we will get that kilometers per hour. That is the way of conversion. Velocity is the rate of change of displacement or that speed in a specific direction. The units for that speed and velocity both are same, that is a meter per second, and there are two different formats for that one. After that, there comes a concept of the distance time graphs. If the distance time graph is a straight line, that means the speed is constant. If the line is like this, such like if you move your pencil on the line that is going parallel to y-axis, that means the speed is increasing. And if the distance time graph is just like this one, you move your pencil on that graph, the line is coming parallel to x-axis, that means the speed is decreasing. And if there is a straight line like this, that means the distance is remaining constant with the time, that means the particle is at rest. For that acceleration is the change in velocity per unit time. We never says about the change in speed because acceleration is the vector quantity and there should come the vector quantity that will change in velocity per unit time. That is also written as v minus u by t. And there comes some questions. Let us do a few after them. What is the average speed of this one? For that average speed, we have a formula that is a total distance over the total time. So you will write down 400 by 20, you will get that answer. For this one, that is 1500 divided by 4 into 60. So your answer came to be 1500 total distance over time is 4 into 60. We will multiply by 60 to get the answer in meter per second. But we can also give that in meter per minute. For that, we have no need to convert in seconds. And that depends upon the requirement of the question. But if there is no requirement, then it is preferred to write down the SI units. Just like this. And that third one, start from rest, reaches a speed of this much after traveling a constant acceleration for this much. What is the acceleration? On that question, we will write down it is starting from rest, that is u is 0, the v is 6, and the time is given to be 3. Hence, we put that in this equation. 6 minus 0 by 3, that will be our answer. Meter per second square. The units for that acceleration are meter per second square, like this, or you can like this. If you have the slash, you will not write -2. If you are going to write this format, then you will write ms -2. We read it as meter per second square. If the particle is going to be speed, negative acceleration is called as the deceleration or the retardation. When the speed is going to be decreased or there is a negative gradient. Now there comes the speed time graphs. If the speed time graph is a straight line, that means its acceleration is zero. Particle is going to move with constant speed. If the line is like this, a straight line, that means the acceleration is constant. And this downward line represents the deceleration. If there is a speed time curve, the curve is like this, that means acceleration is increasing. And if the curve is like that, VT graph, move your pencil on that one. As a result, the line is coming parallel to the x-axis, hence the acceleration is decreasing. That means that gradient is going to be decreased, that acceleration is decreasing. Like this is the curve for that decreasing acceleration. And from the speed time graph, the area under the graph gives us the distance moved. This gives us the distance moved, that is the area under the graph. Area under line or that graph. While that the gradient give us the acceleration. The rise over run, the rise over run, the gradient of that speed time graph is equal to that slope, and that is equals to the acceleration, that is equals to rise over run. Just for this example, that is going to start from 20 to 40, so its rise is 20, and its run is given to be 5. So this 20 over 5 give us the acceleration of this moving particle. Here is going to describe the distance line graph. You must have to see them. Okay. Let us do the questions. These are the graphical. You have to, from this figure 1.23, see, determine the acceleration at 1 second. This one. For such questions, we have to find out the acceleration at a particular instant. For that, we draw the gradient at that point. We will draw the gradient line touching the curve at that single point. Then find its rise over run. This will give us the acceleration at that instant. This A is equal to V minus U over T, V minus U by T. That is also called as the first equation of motion. And the different formats for that equation are AT is equal to V minus U, or that V is equal to U plus AT are the different forms of this equation. Also, we have the equation that every speed is equal to the V plus U over 2. But there's a condition for applying that one, that particle should have to move with a constant acceleration. If the acceleration is not constant, we can't apply this equation. But on the other hand, the equation for that average speed, that is the total distance over total time, that can be applied in any situation. So we can equate both of these. S over T is equal to U plus V over 2, or that S is equal to V plus U over 2 into T. Okay, these are the put in practice and you have to do them. Athlete start from rest at a constant rate of this much for the first second and find its final speed. It is going to start from rest, that is U is 0, the acceleration is 5, 8, the time is 4. We have the equation A is equal to V minus U over T. Instead of A, there is a 0.8, and final speed is to be found. Initial is 0, the time is 4. Solve it, you will get the final speed. For the falling bodies, once we drop some particle, all the particle move with the gravitational acceleration. The condition is that the air resistance is negligible for them. For that, there is no air, or the mass of the particle is too much high. And we represent the gravitational acceleration as A is equal to the G, and its numerical value is 9.8 meter per second square. If we are going to be drop the two particles in the vacuum tube, the coin and the paper will fall with the same acceleration in that vacuum. Their VT graphs will be straight line for both of these. For the paper and the coin, we will get the same type of the graph. But if air is present, if air is present over there, for that paper, we will get the graph like this. Initially, it will fall with a constant acceleration, then acceleration decreases to 0. We will get such like. And once its acceleration becomes constant, that fall with a constant speed, that constant speed is called as terminal velocity. Terminal velocity is the velocity of freely falling particles at constant speed. And for that coin, the VT graph will be the same one because for the coin, the weight is so much greater. Hence, that will fall with the gravitational acceleration. The acceleration of free fall is given and its graph. Okay. Let us start with this question. 8. An object fall from the worker hit the ground at this speed. For how long it takes the object to reach to the ground and their fall? Sketch its graph. Its graph will be that is going to be fall from the rest, and that goes to the 30. We will get a VT graph with the straight line. We have to find out its time. A is equal to V minus U by T. Acceleration is 9.8. The final speed is given to be 30. Minus 0 because it has been dropped over that T. We will solve it and we will get the time for that. Now there are the exam style questions. You have to try for all of these. Let us do a few of them. Just like this 3. Distance time graph is shown in this picture. Okay. How far the girls travel? How much distance is travel? That is 60. Answer is 60. How long the ride take? That take 1 p.m. to 6 p.m. That is 5 hours. Average speed, that 60 by 5. Total distance over total time. The number of stops made by the girl. The first stop is over there when it is parallel to x-axis. Second stop is over there when it is parallel to x-axis. There are 2 stops. The total time for the girl stop over there, that is a 30 minutes, and that is a 1 hour. You will write down 1.5 hours, 1 hour 30 minutes. The average girl excluding the stopping time, that total distance is 60, and we will subtract this 5 minus 1.3, that is 3.5. We will get the answer. Just like this, it's state in which region this the car is accelerating from O to A. Decelerating D to E or B, that is D to E. Accelerating के लिए हम BC भी कह सकते हैं. We can say about that accelerating to BC, there is a DE. Every value of the acceleration at the deceleration or a constant speed in this region. acceleration, deceleration, or constant. The acceleration over there is rise over run, that is the 80 by 1. The deceleration in this region is that 100 over, that is 0.5 kilometer, that is the kilometer per hour square. Kilometer per hour square, and that is the kilometer per hour square. Total distance traveled. We will find out the distance traveled over there. Area of triangle 1 over 2 into 1 into 80 plus area of this rectangle, that is the 80 into 2 plus the area of this trapezium. Trapeziums 1 over 2, sum of parallel sides 80 plus 100 into 0.5. Area of this rectangle, that is 100 into 1. And the area of triangle 1 over 2, 0.5 into 100. This can also be done by this method. You divide that into a rectangle. This is a trapezium. This is a trapezium. There are two trapeziums. You find out their areas and add up them. You will get some answer. Okay, beta, you have to try for this whole one. And if there is any problem, please discuss in group. Okay, Khuda Hafiz.